YouTube live so we can start together. Luis, it's with you.
Thank you, João. It is an honor and a pleasure to be here and have this opportunity to share with you a few ideas and maybe, exercise your mind and your ability to gather together concepts and build your own model of the universe. A foreword. Probably I should have done this before my first presentation to you. You are probably aware that there is something called EADE. EADE is a set of books. It's comprised of five books published about 10 years ago in 2013 by the Brazilian Spiritist Federation. It focuses, or it aims to be, a guideline for in-depth study of the Spiritist doctrine. I have been using the EAED materials and guidelines as a reference to my studies and as a reference to my presentations. In the clarifications chapter, in the beginning of each volume of the study, there is this comment. The theoretical study of the Spiritist doctrine developed at EADE is based on the works of the codification and on those complementary to them. Whenever necessary, such orientations are compared to universal philosophical, scientific, and technological knowledge present in the culture and civilization of humanity, with the intention of demonstrating the relevance and actuality of the Spiritist doctrine. So EADE defends that we Spiritists should analyze and compare universal philosophical, scientific, and technological knowledge with the Spiritist doctrine, according to the Federation, to demonstrate their relevance and actuality. In my opinion, it's a little more than that. I've been asked, why talk about philosophy and science when you are teaching Spiritism? Why, mix those concepts together and comparatively with Spiritist teachings? I have an analogy, and I'm going to waste a minute here sharing it with you. I think of ourselves, all of us, as children, but think of yourself as a child, or of us as children, living in an isolated backwater environment with very limited knowledge. 7 years old, maybe 8 years old children, like the picture.
Children.
Children. Did I say the wrong
Children.
word? Children. Correct me, please. Children. And let's suppose that from somewhere, teachers arrive, not missionary, teachers. And those teachers, they tell us of wonders, ideas we can barely understand. They tell us of cities, of machines, of other things. And they tell us that, people that live there, they are just like us. As we learn, as we hear from them, even though people say, don't listen to those teachers, that has nothing to do with us. Here we have a simple life. We live from the earth, we live from fish, but hey, you are kids that are curious. You want to know things. You want to learn how to fish. And as we learn, we develop ourselves and we discover things. We expand our horizons. As we develop, maybe we'll later grow older, we'll later leave this backwater where we are right now, and we will go to a city and we'll learn things. Maybe we become, much more specialized on something as those teachers that, gave us the first ideas to us. Sometimes we feel like this regarding our grade school teachers, don't we? But they were the spark. We understand their limitations. We understand that their explanations were simple because they had limited knowledge, because we had very, very, very limited knowledge and vocabulary. And this is the analogy I like to do with the teachings that we receive from all those fantastic benevolent spirits that have, dedicated to sharing with us their view of the universe, either in the codification or in the additional works. And I believe that we here, by seeing the convergence of the teachings that we have received from the Spiritist teachers and the discoveries that we have been making, we get closer to perceiving reality as it is. And that's why I dedicate so much of my energy to sharing with you a lot of these converging aspects of human philosophy and science and Spiritist thoughts. So if anyone asks you why you want to study physics in a Spiritist class, please think about this argument. Or if you wonder yourself. Anyway, we live in a reality that we do not know. We do not know the reality that we live in, and that's a fact. Matter, as such, is part of this unknown or partially known reality. In The Consoler by Emmanuel, psychographed by Chico Xavier, I believe it will be available soon in English, won't it, Susara? Emmanuel.
Sorry, are you okay? Go ahead.
I said, I believe The Consoler will be available soon in English, won't it?
I guess 6 months from now.
Good. Anyway, Emmanuel tells us, and you'll be able to read by yourselves, that according to him, humans have the conceptualization of matter just as much as possible for the human mind to provide. There will always be a limit on humans' observation of matter, force, and movement. According to Emmanuel, we are intrinsically limited on what we can understand. We cannot understand reality. We can only approach the comprehension of it and approach the comprehension of matter. Actually, it's very interesting because modern science believes pretty much the same. This gentleman in the picture is someone you know, but probably not as young as this. This is Stephen Hawking. He's the author of many books. He's a well-known person, although he never won a Nobel Prize for his achievements. He is very recognized, and until recently he sat on the Newton chair in Cambridge. Anyway, in the universe on a nutshell, Hawking tells us, according to this way of thinking, he's talking about positivism. A scientific theory is a mathematical model that describes and codifies the observations we make. A good theory will describe a large range of phenomena on the basis of a few simple postulates, and will make definite predictions that can be tested. If the predictions agree with the observations, the theory survives the test, though it can never be proved to be correct. He goes on, if one takes the positivist position, as I do, he means himself, all one can do is describe what has been found to be a very good mathematical model and say what predictions it makes. One cannot determine what is real. All one can do is find which mathematical model describes the universe we live in, or more closely resembling the universe we live in. He's saying, guys, pretty much the same as Emmanuel said there. Isn't that neat? By the way, this picture is he's a little older. Actually, he has passed away. I have something here that's blocking my view. Okay, now it's better. He has passed away on 76 years old, I believe, maybe 2 years ago. And he was badly deformed by his illness. He had Gehring disease. But it's very interesting. Some of his findings have a lot to do with my last slide today. So remember this gentleman. In a very broad sense, philosophy and science define matter as one of the principles that constitute natural reality. Whatever reality is, this universe, a simulation, whatever, matter is one of the principles that constitute it. By the way, I am reading the slides because there's people who is just connected by phone. So this way I can share more of the slide with them. Back to the ancient philosophers, they defended the idea of the existence of a single principle that formed all types of matter existing in nature. Thales de Mileto, he was a very wise man of Greece, about 600 years before Christ, understood that the primordial element was water. Anaximenes and Anaximander, other philosophers a little later than him, believed that air was the single principle that formed the universe. Now Heraclitus thought it was fire. And a gentleman later came, a guy called Empedocles of Agricanto, another Greek, and said, well, there are actually 4 fundamental elements. He agreed with water, air, fire, and he added one, earth. Anyway, you probably saw this water, air, fire, earth in a movie. It has been repeated. But the important thing here is not they being any of those. What stands out in this line of thought is not the type of the elements, but the understanding that there was a generating principle of matter. Something that we in Spiritism call universal cosmic fluid or primitive cosmic matter, or the one I like the most, universal fluid. Those guys must have been inspired, being able 2,500 years ago to come up with this concept when looking at everything around them. So different. In the Spirit's book, Kardec tells us that matter consists of one single primitive element. He tells us the bodies you regard as simple are not true elements, but rather transformations of the one primitive matter. We will see later how current scientific theories says pretty much the same, tells us pretty much the same. And Kardec goes on. The different properties of matter come from the modifications that the elementary molecules, obviously molecules here do not mean chemical molecules, but the small things that the elementary, very small things undergo as a result of their combining under certain conditions. In the early years, a very common philosophical interpretation of matter was matter as an entity or potency. Let's digress a bit about this. For philosophy, matter is a real potency because it contains something. Plato and Aristotle considered matter an entity or a potency. This text on the left is one of Plato's tests called the Timaeus, very, very famous. It's actually a collection of Plato's teachings that was edited by someone after he died. And Plato said that it was an entity because matter was seen to be the mother, the generatrix of all things that exist in nature, except the spiritual being. So Plato may be the first one to consider everything is matter except the spiritual being. This text on the left, by the way, is a translation of the Timaeus into Latin. Actually, this is not the one, but the first translation was made by Marcus Tullius Cicero around 50 before Christ or something like that. Aristotle called it a potential reality. And taking it straight from Timaeus, matter hosts all things within itself without ever assuming any form. It's like wax that receives the mark. This is neat as well. Grab this concept. For Aristotle, potency is the same as possibility, the capacity to be or not to be. The passage from potency to effect reflects the execution of a possibility, the execution of a previous potential. It also means to say that anything in nature did not arise miraculously or by chance, but from a pre-existing potential, equivalent to the symbolism of the tree that originates from the sea. For Aristotle, potency is not just this pure possibility of being or not being. It's an operative and active power. Aristotle, before, in a time before Christ, was saying that matter is an operative and active power. That is so neat. In his work, Metaphysica, and on the left you see a page of Metaphysica. It comes from the Vatican Library. It's obviously a translation into Latin. But this way you can tell, your kids that you have seen an image of Metaphysica translated into Latin without going to the Vatican Library. But anyway, Aristotle tells us that he has potentially exists if there's nothing in its material that prevents it from becoming a house, and if there's nothing else that must be added, removed, or changed, this self-sufficiency of the potency to produce, thanks to which matter is not just raw material, but effective capacity for production, expresses a concept that is no longer of matter as something, as passivity or as receptivity. So for Aristotle, matter itself has potency. And he continues, as an operative potency, matter is not necessarily corporeal. According to Aristotle, matter may be incorporeal. I have your video on my right, that's why I look right sometimes. Sorry about that. Then we go on to the Middle Ages. There is a philosopher of the 12th century called David of Dinan. Dinan, by the way, is a Belgian city. And you are seeing a current picture of Dinan on your left. You can see that the fortress on the top is very, very old, probably as well as the cathedral. The understanding that matter could not be necessarily corporeal gave rise to numerous discussions over time, especially in the Middle Ages, at the time of the scholasticism. For those who are not current, scholasticism, not current, but aware, scholasticism was a Christian school of thought in the Middle Ages that tried to reconcile rationality based on the tradition of the Greeks and the Platonism, etc., and the revealed truth brought by the Christian faith, actually by the Catholic Church. And the scholasticism trying to, bring together those truths. Remember, we are not at the Carta time anymore, 400 years later. We are at the very dark, dark spot in the Middle Ages. So this David of Dinan actually proposed the concept that God could be a being made of matter. And for these and other ideas, he died in the Catholic Inquisition. So we should be glad we are not, in the very dark part of the Middle Ages. Later, 16th century, a gentleman called Giordano Bruno, whose drawing is shown on the left, he was actually a Dominican friar besides being a philosopher and writer. Describes matter as the active and creator principle of nature, present in all bodies and capable of generating infinite other types of bodies. As you can imagine, he was convicted of heresy and killed by the Catholic Inquisition. Not only for this idea, but for others. On the left, I have transcribed some of those ideas, but he says that God is the reason and the origin of the universe. He's the one who defined the things that form the universe. God is the universal intellect that animates, grounds, and governs the world. He is the one who gives existence to the things of the universe. Oh, well, I don't know why the Catholic Church didn't like his ideas, but at least the ideas I wrote here. But unfortunately, he was convicted. A little later, Descartes, who fortunately was not killed by the Inquisition because he contributed so much to us. Remember, I already told you about him. He was one of the first in this renewal of knowledge. He stated that the nature of matter does not consist of something being hard, heavy, colored, or capable of affecting our senses. Descartes defines matter as an extension. Matter is what occupies space with length, breadth, and depth, just like the brick on your left. As simple as that. Later, next century, I got some. Do you hear me? Thank you. I got just some strange noise. Anyway, if anything goes bad, please shout. Later came the concept, different concept, of matter, not as an extension, but as force or energy. This idea obviously has a Platonic background, and it was introduced by 14th century, 17th century, philosophers with a Platonic background at the University of Cambridge, including Newton that I already mentioned, and Leibniz. The scientists, the scholars, consider matters as something solid, but with a plastic force, whose modifications took place in its interior, but it kept shape and type. It's not saying much there, is it? Leibniz, in addition to extension, said that matter had a passive force of resistance called impenetrability, or antitypia from the Greek. At this time also, it got strength the concept that matter was formed of very small, indivisible particles called physical monads. The word monads appear here, different meaning than we use. Anyway, by the way, I didn't comment, but this is a painting of Newton, Isaac Newton, Sir Isaac Newton. This is Leibniz, nice styled hair, isn't it? And this is another view, no, it's not a view, it's Kant, Immanuel Kant, who said that matter fills space, not through its existence, but through a particular driving force. That's an insight that's fantastic as well. How inspired Kant was probably at this time. Newton said that it's impossible that matter should be free from tenacity and friction, but this is not very interesting in our concept, in our context. Another German philosopher, some years later, stated, this is Schelling, by the way, in the picture, and he stated that matter has three dimensions that are not actually dimensions, they are three forces that constitute matter. They would be expansive force, attractive force, and a third, the synthetic force, which correspond to magnetism, electricity, and chemistry. Those would be the forces that determine matter. Coming to the 20th century, the concept of energy was incorporated into that of matter, promoting a lot of debates. In our present day, if you go to, by the way, is the image moving to you?
Yes.
Okay. Thank you, Wayne and João. I have a few moving images in this presentation. They should help clarify some concepts. If you go to your high school textbook, you probably would find a definition of matter very similar to this one. Matter is anything that has mass, takes up space, and is subject to inertia. More about inertia a little later. Matter is something that exists and that enters into the composition of bodies and substances. Today, we understand that mass also deforms space, like in the picture. If you see this moving mass in this quadriculated cube, what we try to show is that the actual presence of mass deforms space. It is a consequence of general relativity that has been proved experimentally. Even recently, Eric, I couldn't include here, but Eric, I don't know if he's watching us, has sent me a fantastic short movie showing how two pulsars, very heavy, that circle each other, have given us experimental proof of the distortion that matter generates on space. He can send us a reference. But let's talk about inertia for a moment. People have a very difficult time differentiating mass from weight. Because here on Earth, the numerical value is the same. It's very difficult for us to understand that this could, weight a kilo and have a mass of a kilo. Actually, weights a kgf and have a mass of a kilo, weights a Newton. But we say a kilo and we mix the two. Well, let's wait 30 seconds and try to understand both concepts. Weight is the force that gravitational attraction makes on a body, and it's what causes this box to fall. Mass, on the other hand, is always the same. The mass of this brick, if I might say, will be the same here on Earth and on space station, in Mars, in the moon, in another planet, in deep intergalactic space. The mass will be the same. And what the mass represents, the inertial mass, is the resistance that a body offers to change their motion. So suppose this is a rock, a very, very, very heavy rock. If it's here on Earth, like in the picture, then I have to move this rock. Suppose it's on rollers, like a car. It will take a big effort. If this rock is in the space station, moving with it, but it's there, and I'm an astronaut, and I try to push this rock, there will be a substantial effort on my part to move the rock. If this rock is coming at me, if it's as big as the one in the image, here on Earth, I won't be able to hold it. And the space station is the same. I won't be able to hold it, and it will mismatch me against the wall. So I hope you grabbed, Marilyn, the concept between mass and weight. And let's talk a little about energy. Energy is one of those words that have multiple meanings, and we have to be very careful not to mix the meanings. My mother, Terezinha, for instance, that probably she's watching, she uses energy with a lot of different meanings. None is the physical meaning of energy. When I say I'm feeling energetic today, I do not think I'm talking about the same energy that we use in physics. It means I am very, disposed, I'm willing to do things. Doesn't mean that I ate a lot of food that had a light energetic content. And, now I am passing out because I put so much energy inside myself. Also, when, one say there's a very bad energy here in this environment. It's not that energy that we're talking about. In physics, energy is the ability to perform work. Energy is everything that can change matter, the position, momentum, aggregation phase, change of state, liquid to vapor, and chemical nature. Energy can create movement, can cause deformations. For those of you who do not have an image, in the left, I have the longitudinal cut of what would be a hydroelectric plant with a dam on one side, where there's a lake of water at a higher level than the downstream. You can imagine that famous electric dam in Colorado, I believe, Hoover Dam, right? That's a very high dam. When the water is inside the lake, it has something we call potential energy. As the water moves in a tunnel, it gains speed. So potential energy is transformed into kinetic energy. And as this water with kinetic energy reaches a turbine, it actually moves this turbine, generating mechanical energy, movement of the turbine. And because this turbine is connected to a generator, an electrical generator, this energy becomes electrical energy. And it will come to our houses, hopefully. Lavoisier, and I remember Marcus Abud, Lavoisier enunciated, among other principles, the principle of conservation of energy. He stated that the total amount of energy in an isolated system remains constant. A consequence of this is that energy can only transform itself, can only be transformed. Nothing is lost. Everything is transformed. What this has to do with matter? Einstein was the first to propose a scientific interpretation of matter as being energy. In a famous paper published in 1905, the name of the paper was The Inertia of a Body Depends on Its Amount of Energy, ? That's the EMC squared came about. He proposed a general principle where mass and energy have an equivalence as a consequence of symmetries of space and time. This is known as the Einstein special theory of relativity. The special theory lasted for 20 something years. It was replaced by the general theory of relativity that include acceleration. But it's very relevant even today because it's simple. We can understand its concepts. With it came a concept that now is in disuse, but the concept of relativistic mass. When a body is moving with respect to us, as its speed increases, this body seems to have more mass. That's one of the reasons why those huge particle accelerators of today have to be so huge, because as they accelerate particles closer to the speed of light, the apparent mass increases and you need a delta energy higher and higher to make it go faster. As if we were, bicycling with the wind in our chest. And as the faster we go, the more the resistance and the higher the effort we have to make. I'll make a point eventually. Bear with me. Now that we talked about the characteristic of matter as energy, let's talk a bit about the constitution of matter. The idea that matter is made of very small, indivisible grains called atoms is very old and appeared in Greece. Recently, 100 and some years ago, a gentleman called J.J. Thompson, you probably heard of this company, Thompson, around the turn of the century, the 1900s, identified that there were particles lighter than hydrogen. That's the lightest atom. Those particles were later called electrons and recognized that electrons carry the electric current. But Thompson concluded that the electrons came from the atoms, which means that the smallest part of a substance was not indivisible. The atoms were made of something. And it's funny because while Thomson and Einstein in 1905 demonstrated that the electron was a particle, actually, this demonstration gave Einstein the Nobel Prize, not his theories on time and gravity. But at the same time, the electron was shown to be a particle. Other scientists, Fresnel, Maxwell mainly, and Young, had already demonstrated that light, and light is nothing but electron beams. Today we call them photon beams, but at the time they were electron beams, to be wave-like. Particle or wave. A guy called Louis de Broglie first enunciated the duality, saying that the electron is at the same time wave and particle. Actually, if you go read, I didn't make a slide, but if you go read the mechanisms of mediunity, I believe in chapter 1 or 2, they tell us, they mention de Broglie. So you can go there and find him in our publications. But this is, I'll spend a minute here. You are seeing this picture, this moving picture in front of you. Those who are not, I will describe it. There is a source of light. It has to be a coherent light. And this light passes through a first slit. Imagine a rectangular slit. Then in front of it, I have another board with two slits. How did you expect the light to be after those two slits? Suppose we place a white piece of paper at the right. Here we are seeing from the top, okay? At the right. What would you expect? I've seen this experiment for the first time in the second year of high school, probably together with João. I don't know if he remembers it. In my ingenuity, I would expect, a plain white light, probably stronger somewhere and weaker on the sides. But that's not what appears there. Incredibly, what appears is the picture that's below it. A series of fringes. We call them interference fringes, where you have like stripes, vertical stripes, as vertical as the slits, brighter in the middle, then lighter and lighter and lighter, but with totally dark patches in between them. How can this be? And the funny thing is that if you close one of the slits, you see a variant, a gradient, smooth, a lighted background. But with the two slits open, you see the interference. Modernly, they can actually throw photon by photon, electron by electron towards the two strips. And obviously it takes time, but the fringes will appear the same way, because statistically, sometimes the electron will pass through one of the slots, and sometimes through the other slot. And they can see the markings there. But it's a probabilistic thing. And the interference that's characteristic of the interference of waves appears. If we try to measure through which fringe the electron is passing, the interference disappears. How can that be possible? Heisenberg in 1927 brought up the uncertainty principle. This eventually evolved into something that we call the collapse of the wave function in quantum mechanics. And please bear with me, because you'll find, I believe, it is interesting and how it matches with some of the teachings that we have received from benevolent spirits. Let's try to talk a bit about the collapsing of the wave function. What a bad term is that? What it actually means is that we will only know when a particle is traveling where this particle is when the wave that describes it collapses. And it collapses. How it collapses? I will use here an experiment. It's called the Schrödinger cat experiment. This is a thought experiment. Imagine you have a cat inside a closed box. Inside the box with the cat, there is a vial with venom. On top of this vial with venom, with a poison, if I say venom, but with a poison, there is a weight. And this weight is receiving radiation. Radiation from a substance. Could be uranium, thorium, whatever. A characteristic of the radiation is that it is statistical. You never know when a nucleus will emit radiation. So we'll never know when this particular Geiger counter that is holding the weight will have received enough radiation so that it will drop the weight and kill the cat. So Schrödinger asked, what is the state of the cat? Is the cat alive or dead? It is the same characteristic of what we were talking about, of the particle that can both be here or there. The answer is, we will only know when we look inside the box. Before we look inside the box, the cat is both alive and dead. Got it? It's alive and dead. We don't know. It has a probability function. Maybe if enough time passes, there's a higher probability that the cat's dead. Maybe in the beginning, there's a lower probability, but he's both alive and dead. Only when we look inside, the function will collapse and we will know if the cat's alive or dead. This thing called the wave function collapse has generated many interpretations. There's the Born interpretation. There's the multiple universe interpretation. But there was one interpretation that's very spiritist. It's called the Copenhagen interpretation. It's been made by scientists. This is not theological, guys. Serious scientists. It's also called the transactional interpretation or the spiritual interpretation. And by the way, the guys have done the math on this. This is not just a crazy idea. It has been defined mathematically. It has been proposed by a gentleman called John Kramer in 1986. And what this proposes or this suggests is that what collapses the wave function is the first conscious observer. At the time a conscious observer sees this, the wave function collapses and a state is defined. It's either here or there. John Kramer did not explain why animals or other living creatures have the right to collapse the wave function. A guy named Wigner, another scientist, proposed a explanation that is the consciousness. Is the consciousness, is that spark we talk so much about, is the consciousness that have the right to collapse the wave function. You recently have studied the book Liberation, haven't you? I'm sure you didn't pay attention to this particular passage. In chapter 1, Flaccus, the minister, gives a long explanation. It's page and page and page. And buried in there, there's this. Matter, according to Minister Flaccus, who is giving, a lecture to André Luiz and others, matter is a condensation of energy, serving the imperatives of the self, which presides over its destiny. He's saying the same thing. He's saying that it's the imperatives of the self that presides the destiny of matter. It's the self that collapses the wave function. And he continues, from hydrogen to more complex atomic units, the power of the eternal spirits acts as the guiding lever of protons, neutrons, and electrons along the infinite road of life. Isn't this fantastic? Back to high school physics. We're going to walk from high school physics to more recent human knowledge of matter that I think comes very, very close to the universal fluid. So I'll be able to tell Marilyn the answer to the question that she has made maybe 2 months ago. What is universal? What do I think universal fluid is? Remember, Marilyn? Anyway, high school book, atom is the smallest unit of matter that forms a chemical element. Remember the periodic table? We have 100-something of chemical elements. And the smallest unit of a chemical element, hydrogen, helium, lithium, beryllium, boron, carbon, is an atom. The atom is made of atomic particles. But there's a lot of empty space inside the atom. And when I say a lot, I mean really a lot. So you have a means of comparison. There's more empty space inside an hydrogen atom comparatively that there is a empty space in the solar system up to the last planet, up to Neptune. If you consider the empty space inside the nucleus, because the nucleus is not solid, there is much, much, much more. We're saying 10,000 to 100,000 more empty space inside the atom than in the whole of the solar system, considering the solar system going way beyond the last planet, up to the beyond the asteroid belt. It's far away, guys. So the atom has a lot of empty space. So matter that's made of atoms is made of elementary particles that also have mass. Elementary particles, not all of them, but many elementary particles can exist in nature without being part of the structure of an atom. Let's get closer to today's science. I learned in high school that atoms were made of electrons, protons, and neutrons. Well, they're not. Atoms are made of electrons, up quarks, and down quarks. In 1964, a gentleman called Murray Gell-Mann proposed the existence of quarks. Quark, if I am not mistaken, is an imaginary personage, imaginary character in some book. I don't remember which. Anyway, quarks were eventually experimentally proven. Actually, in the United States, in the Stanford Linear Acceleration Center, in the SLAC, around 1968, I believe, if I'm not mistaken. As a curiosity, a quark cannot exist in isolation. It's one of those particles that cannot live by themselves. They are always combined to other quarks. This is called quark confinement, and it's a principle of particle physics of today. So as you can see on the picture on the left, a proton that we learned in high school is actually composed of 3 quarks, 2 up quarks and 1 down quark. And a neutron is composed of 1 up quark and 2 down quarks. So protons and neutrons, they are not basic particles. They are made of quarks. Emmanuel, in the consoler question 16, he tells us, atoms and electrons are phases of matter characterization. They do not constitute the origin in this endless spiral towards the plane of the infinitely small. This is in a part of the consoler where he talks about physics. Hey guys, I hope I'm not boring you to that. Anyway, to be complete, there's a 4th type of fundamental particle, the neutrino. So everything that we know in the universe around us that constitutes the matter that we touch is made of electrons, up quarks, and down quarks. Everything. But there is a 4th type of particle that does not combine with the others very well, does not interact with almost anything. It's called a neutrino. So to be complete, everything that's around us is composed of electrons, up quarks, down quarks, and neutrinos. Neutrinos are produced by stars. They were also produced during the Big Bang, the beginning of the universe. And there are a huge number of neutrinos around. In 1 second, 10 trillion neutrinos pass through our bodies. Because our bodies are made of atoms, and because atoms have so much free space, so much empty space, very few of those neutrinos interact with our atoms. They just go by us. They have actually, to study neutrinos, they have very large pools. But I mean large, very large, like million tons of waters with facto detectors. And they have to be, built very, very deep underground, below lots of rocks, so that the cosmic rays do not reach there. And those pools will detect a neutrino when it hits a molecule of either hydrogen or oxygen, like a few times a year, a couple of times, 4 times a year, so that you can feel, how very seldom they interact with us. I couldn't talk about current physics without talking about the standard model, and I'm trying to finish this in 10 minutes, everything. So very fast, I'm gonna go to the standard model with you. This is very recent stuff. As you can see, I'm quoting many things from the Quanta magazine. You can find them on the internet. This is from a June 10, 2021 issue. But anyway, and they have nice pictures, so I use their nice pictures. The 4 matter particles that I told you about, are four fundamental particles of the standard model. But the standard model has other particles. For reasons that we do not understand, there are 12 matter particles. They do not appear in everyday life, but we can create them. And they probably appear inside stars and inside black holes, but they do not constitute matter around us. I will not go into details on this because you will die of boredom. Anyway, all those particles are described by the same equation. It's called the Dirac equation. Don't try to understand it. It's a relativistic wave equation that was originally developed to describe the electron, but it actually described all fundamental mass particles. Woohoo! The plot thickens. So, in Mechanism of Mediumship, André Luiz tells us, the more matter is studied, the more it is revealed as a bundle of forces in temporary association. We have him, it means the human, actually it was man in the original, but we have him, the human, in this way, as a traveler of the cosmos, breathing in a vast empire of waves that behave like mass. That's what Dirac equations tells us. Particles are waves that behave like mass. But the Dirac equation could not account for everything. And by the way, this moving picture on your left shows on the top, maybe you should see just the B on the top. You see an harmonic oscillator in the form of a mass and a spring. Goes back and forth, back and forth. Actually, considering the Dirac equation, what you have is the age diagram. You have a probabilistic wave of where that moving mass will be in a certain moment in time. So watch B is in banana and H is in hotel. Anyway, what the Dirac equation doesn't account for. Photons, for instance, cannot be fully described by the Dirac equation. Radioactive decay is impossible to explain. A major component was missing. Very shortly, there are other particles in the standard model that carry forces. The photon, the Z boson, the W boson, the gluon, and more recently, the Higgins boson that generates the Higgs field. The one people was talking about, that would be the God particle that was experimentally discovered in 2013, I believe, by that huge hadron accelerator in CERN between French and Switzerland, close to Geneva. Anyway, just so that you can tell your next of kin that you know the standard model of particles. And this gentleman, his name is David Tong, and I'm using his words here. He is a theoretical physicist at Cambridge. This is a very recent image of him. There's a lot missing in the standard model. Gravity is not described by it. Antimatter is not described by it. And we know that antimatter exists probably you guys have done a medical exam that's called PET scan. PET scan is positron emitting UT, I don't remember what it is. Anyway, it's an examination machine that detects positrons. We don't have a positron in the standard model. And besides this, the dark matter that we have talked so many times about and constitute 95% of all matter and energy in the universe, it's not described by the standard model. So David Tong tells us there are patterns in particles suggesting that there's a structure that forms them waiting to be discovered. A new layer of reality beyond the standard model. I made sure to cut this image of the movie, of the short movie by David Tong that you can search in the internet with the subtitles. So he is telling us that the structure, something lies beyond the standard model. So let's talk about the state of the art of the constitution of matter. 2 slides only. I'm using the article from Kevin Hartnett, and there are texts here from Kevin and from David Tong. It's common to think of the universe of being built from fundamental particles, like electrons, quarks, photons. But physics long ago moved beyond this view. Instead of particles, physicists now talk about things called quantum fields as the real, his expression, warp and woof of reality. Matter at a fundamental level is not made of particles, is made of fields, fluid-like, his words, fluid-like objects, which are spread through all of space. These quantum fields extend to the space-time of the universe. They float like moving ocean. And as the field ripple and interact with each other, particles appear and then disappear, like the crest of a wave. Dave Tong tells us that particles are not objects that are there forever. They are the result of a dance of fields. As the fields interact fluid-like, the particle that's in the ripple of the fields appears to be moving. Actually, the equation for a moving particle can be described as this particle here just disappearing and appearing ahead, disappearing and appearing ahead, disappearing and appearing ahead, disappearing and disappearing ahead. So matter could be something that is appearing and disappearing in very, 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 very small slices of time, quantum slices of time, as a result of the crisscrossing of waves that constitute the universe. You've heard something like this before. By the way, this moving thing here on the right is an actual graphic visualization of a mathematical calculation using quantum field theory, showing virtual particles in a quantum vacuum, considering only the strong interactions. the strong force, okay? I thought it was neat to show it to you. Let's finish with a couple of spiritist considerations so that you can think about all that we said historically, recent physical interpretations, and you can reason about the convergence of both. Emmanuel, in the Consoler again, question 17, share with us that modern notions of physics are getting closer and closer to the knowledge of universal laws. The old systems have aged. Yesterday conceptions have given way to new deductions. This figure on the left shows the Earth and the Sun deforming space. Their mass is deforming space. It's shown here in 2 dimensions. It's difficult to imagine in 3. In the Spirit's book, question 33, Kardec tells us that the same elementary matter is capable of undergoing all possible modifications and acquiring all possible properties. He could be talking about those fields that form the particles with different words. In Mechanisms of Mediumship, the preface by André Luiz tells us that the more humans investigative nature, there should be an apostrophe there. The more humans investigate nature, sorry, it's correct. The more they become convinced that they live in a kingdom of waves, transfigured into light, electricity, heat, and matter, according to the vibratory pattern in which they are expressed. A modern physicist could have said that. He continues, there are, however, other manifestations of light, electricity, heat, and matter, unknown in the range of human evolution, of which, for the time being, we can only gather information by the ways of the Spirit. In Genesis, chapter 14, Kardec tells us that the universal fluid is the primitive elementary matter, and it can generate 2 kinds of matter, 2 distinct states of matter. Materialization, and that's the matter we know and surrounds us. And it can exist in an etherization form that generates a number of different kinds of matter. And according to him, much more numerous than the kinds that we know of. Millions of variations that constitutes the environment of the ethereal spirit and how they do their technology, because we have read in André Luiz's book, they have a technology, it's quite advanced, it's just different from us and from ours and handled different instruments, different tools. So everything is universal. Fluid, everything is the result of waves like ocean that interact and produce the particles that we treat as particles because it's convenient, but they are just the interference of waves. Isn't that fantastic? Emmanuel, in the Consoler again, question 17. Recent studies of matter make you aware that its elements are dissociated by analysis, that the atom is not indivisible, that every material expression can be converted into force, and that all energy returns to the reservoir of the universal ether. In time, the academic formulas will be renewed in other concepts of transcendent reality. And Earth physicists will not be able to dispense God in their relations. The funny thing is that, remember that scientist, Stephen Hawking, the guy who wrote this, he's an atheist, or he was an atheist, but in consolidating the concepts behind the Big Bang and the, I forgot the word in English, he essentially demonstrated that there was a creator that in a certain moment, 13 to 14 millions of years ago, measured by our time, created the time and space of our universe. So today's physicists cannot dispense a creator. I hope you have enjoyed. I hope I have brought to you some new concepts, some things to think about. I hope you have found, seeds of the convergence of modern physics and spiritism regarding matter. Has it been fun?
Very interesting. Wayne just wrote a comment there that made his head hurt.
Sorry about that.
One thing I think it's important really to reinforce here is that the consoler was written in 1938, right? So way before all this modern science came. So the concepts that all modern science concepts are being brought was kind of anticipated by Emmanuel in 1938.
I know that we have discussed things that are way beyond our high school physics. And I don't expect you to have, absorbed everything. A lot of material here. We could talk, days about this. But if I have opportunity to give you a glimpse of this convergence, I think I'm doing something interesting. Because again, spiritism is reasoned faith. It's not blind faith. So we must have a chance to reason, to compare learnings, to see how, reality is one and the same. It's just that we know so very little of it. As we learn, we have the opportunity to have teachers, to have those spirit benefactors that, spent so much energy trying to tell things to us, to show us how they see the universe. And it's fantastic. And that analogy that I do is true, it's sincere. I think we are children that, had the opportunity to have teachers here. Were we in the Middle Ages, we probably, would be right there with Giovanni Bruno by talking about these things. Philip, did you enjoy it?
Yes, definitely.
Mary.
Thank you. Arlie.
I agree with Wayne. It was mind-boggling, and I'm going to have to view this probably several times to further understand the concepts. I do understand it in a rough way, a simple way, but I think it will take future viewings to get at the depth of it. Thank you, Louise.
I try, again, this is not, minced meat. You've got to cut it and chew it. So I try not to do that for you, but I find it very interesting that today's scientists are saying that matter is made out of the fluid, of the interference of fluid.
Yeah.
Wave-like structures that vibrate. Come on. I mean, when we notice the theories of people 2,000, 2,500 years ago, they had to be inspired. How could they come up with something like that? When Jussara tells us about, inspiration, that's one of the reasons why I share so much philosophical, historical views with you. Because we have a chance to see inspiration in action.
Thanks, Luis.
A lot of questions.
Any-
Huh?
we have a Q&A next Sunday, so you guys can think about the questions and bring them next Sunday, and Luis will be here, so he can answer the questions next Sunday also.
Not
because
even
today
usual.
we are close to the end.
Not
It's,
even
you
usual.
know.
I have a question for me. My brother gave up. My brother is a doctor. He started watching the lecture, and I think he
Gave up.
exploded.
Gave up in the middle of it.
Thank you, guys. Thank you for the
Thank you,
opportunity.
Luis.
I had a
We
lot
really
of fun researching this. There's a lot of research in that. You can imagine how much. Enjoyed it
Yes.
immensely.
We really appreciate it. Thank you very much. So as I
Sarah looks
mentioned,
like she has questions. She is smiling.
Yeah, no. Ay, ay, ay.
okay.
I have
So
a lot
next
of
Sunday,
questions, but I have to go through them myself,
so next Sunday we are going to have our Q&A. Oh, go ahead, Paco.
Yeah, it was kind of what the gentleman said, a lot to digest. But Louis, you were successful, because we heard about the cosmic fluid or the cosmic fluid or the cosmic fluid, but you were kind of successful in conveying the intricacy and complexities, containing that concept. It was just not just cosmic fluid, so you were successful in conveying that message.
Thank you.
Despite the fact that, definitely the subject matter is difficult, but definitely now I have a little more kind of sophisticated understanding of the cosmic fluid, which was basically before kind of plain. I don't want to, but now I do have a much more kind of vibrant, I would say, of the complexities of the concept. Thank you.
Paco.
I want to thank Jussara for her wonderful lecture earlier this morning. I saw it. Thank you.
Thank you, Marilyn. I'm happy you could join us.
That was at 10 o'clock? That was the one at 10
Yeah,
o'clock?
the initiation into spiritism.
Yeah, I wanted you to join that. I didn't get the book. I ordered it. I don't know what happened. I have to check.
Oh, because it takes Amazon takes 2 to 3 weeks to deliver, so you should be getting. Yeah, it's printed by Amazon and sent. So, but you should be getting shortly.
Okay, so
And,
I want to. So Jussara started the. Is Jussara teaching that?
Well, each week is a different person, presenter. Luis has a couple of presentations. I have one. We all have different presentations, but the first one today was Jussara. Next week is Glaucio, that is going to present. I forgot what's the subject. You may remember. But if you missed, you can always watch. It's on the US. Yeah, you can go to the United States Spiritist Federation page and watch it there.
Okay.
It's going to be about God and creation.
The first one today was Jussara. Next week is Glaucio. God and creation. Okay. All right. So, Carol, can you do our final prayer? Oh, Carol is gone. Sorry. Zoraida, can you do our final prayer?
Yes, of course.
Thank you.
To our spiritual benefactors, our guardian angels, to all that have participated here in our meeting today, giving thanks to our brother Luis for his presentation, and understand how much we need to continue our studies. We are grateful for that, opening our hearts to what is important to us. We ask as we continue throughout the week, again, continuation of studies through our meetings with our brothers and sisters. We pray, dear Father, for our brothers and sisters that are going through difficulties still through this pandemic. May our Father bless and keep them safe. We pray for the United States Spiritist Federation, United States Spiritist Council, for all the work that they have been doing for us, understanding the need for the studies and who we are. We pray, dear Father, for all that are in need in hospitals and hospices, for those that are in undeveloped countries, for their needs. Dear Father, may we continue throughout the week with our prayers and ask to bless our families and keep them safe throughout the week. We are grateful, dear Father, for our meetings today and continue again next week. With our hearts full of gratitude, dear Lord, we thank you and we ask permission to close